Well, hello, this is Dr. E, beginning our first chapter in our course on integrated science. This first chapter is about science, a way of knowing. Now, let me first tell you a little bit about the overall structure of this course. You will find a file called syllabus, and that file will contain additional information about how the course will operate. Depending upon the semester, the course will involve these video lessons in addition to some face-to-face lecturing and some classroom activities. So look at the syllabus to find more details for this particular semester. When there is video content, you will be asked to view the video lectures before coming to class so that you can more actively participate in the activities during the class itself, which may involve discussion or working some problems or actually doing some experiments. The videos will generally be broken into smaller segments of maybe 10 to 15 minutes, interspersed with quizzes where you will have to answer the questions or else have an opportunity to review the video content. After you have viewed a number of the videos, you will be able to then print some condensed notes on the material. So let's begin with this first chapter on science, a way of knowing. Science is a way of asking and answering questions about the natural universe. Now, science is not the only way of acquiring knowledge, or what we assume to be knowledge. You can also acquire knowledge from a trusted authority, from your own reasoning, from your intuition, or from inspiration. These other ways of knowing are more appropriate for a number of issues, such as truth and beauty and justice and goodness. Issues that are beyond the realm of science. But when it comes to understanding how things work in the natural physical world, the methods of science have proven to be universally adopted. And let's quickly give a very broad overview of the type of things that science has providing an understanding about. I give a list here of things, and we will actually be talking about these topics in this course. Newton's laws, the laws of thermodynamics, electromagnetism and electromagnetic radiation, the theory of relativity, chemistry and the periodic table, the molecular basis of life and genetics, and a theory of plate tectonics. Now, the first semester of this course will focus on the first several of these topics, and the second semester will go more into geosciences and to biological sciences and biomedical sciences, to give you an idea of what is in store for us. Now, this scientific method or scientific approach took a while to be developed by mankind. Early philosophers attempted to understand the natural world by reason alone. And in this slide, I show you some images of a few of these early philosophers: Plato, Aristotle, Ptolemy, others, Socrates, Democritus. These early philosophers essentially relied on thought processes. For example, Democritus in ancient Greece rationalized that if you attempted to divide matter repeatedly, cut it in half and cut it in half and cut it in half, that at some point you would reach an uncuttable smallest particle called the atom, or atomos. We will talk about this later on in our chapters related to chemistry and atoms. And in fact, that concept still survives. Plato, Ptolemy, and other natural philosophers even thought it was risky to trust one's senses to try to understand the world. They believed in trusting the eye of the mind. Plato taught that one should use the mind and rationalization rather than sensory organs to understand truth and the universe. There's a story about how a group of philosophers were pondering the question of how many teeth a horse has. And when someone suggested actually going out and finding a horse and counting the number of teeth, they rejected this as relying too much on senses, which may be fallible. But over the centuries, there emerged what we now recognize as modern science. We call this the scientific revolution, which really took place largely between the years 1500 and 1700 and involved a number of the scientists shown at the bottom: Copernicus, Kepler, Sir Francis Bacon, Galileo, Newton. We will be talking about some or all of these individuals during the class. They essentially developed the empirical approach, empiricism, which relies on observations, including experimental approaches. This use of empiricism, empirical approaches, we now refer to as a scientific method. Now, of course, it would logically have taken centuries for the experimental approaches to take hold, because one would need some type of instruments, microscopes and telescopes, and ways of weighing and measuring length. And that gets to our next topic, the importance of measurements in mathematics for empirical experimental methods. And the ability to measure things also had practical importance in trade and construction, etc. The most important of these, which we will talk about, are the ability to measure length and weight, which we will see is actually mass, and time. One had to know, for example, when to plant seeds and how many seeds to plant in order to produce a sufficient number of bushels of grain for the winter months. For construction of buildings, such as the pyramids, these early engineers would have to be able to predict how high to make something and whether or not corners were square, etc. In commerce, there had to be units of measure and ways to consistently determine how many bushels of grain might be equivalent to a certain number of livestock, for example. And of course, in warfare, how fast is that Argonaut ship approaching us anyway? So for all of these practical reasons, as well as scientific reasons, units of measure and the use of mathematics had to be developed. And we also needed the development of measurements in mathematics for the study of what we would now recognize as more fundamental scientific questions, such as, do heavier objects and lighter objects fall at the same rate? Okay, we will pause now, and you will be given a brief quiz. And after you answer a certain number of questions correctly, you can then go to the next video lesson, in which we will talk more about these units of measurement: time, mass, and length. Okay, see you in a while.